we are going to find limits at infinity. What does that mean? Well, it means what the graph is doing as the x values go on forever in both the negative and positive direction. The limit as x approaches positive or negative infinity of a function. So is your graph, for instance, if you have an axis like this, is your graph going, for instance, like this? As you go on to infinity, doesn't this graph go to positive infinity as you go this way forever? As you go this way, doesn't this one go on to positive infinity? Alright, if you had a graph like this, and then it goes like that, well, this is called a horizontal asymptote. This graph is going to go on to this horizontal asymptote, never touching it. This one goes on to negative infinity. So it's what this graph is doing as you go to the left and to the right. Is it going to be an asymptote? Is it going down forever? Is it going up forever? What's happening on the edges of your graphs? That is what a limit at infinity, or the limit as x approaches infinity, or negative infinity, is doing. Alright, so how do we do this? First, if a limit results in an indeterminate form, which is basically infinity over infinity, okay, when you take a limit to infinity, but when you have this situation, then divide both the numerator and denominator by the highest degree in the denominator. Okay, that's the process we're going to do. For instance, when I plug in infinity, because that's what you do with a algebraic solution to a limit, you plug infinity. When I plug infinity into all these x's, I basically get, when you put infinity over another infinity, which we said is indeterminate. So I can't determine that, so the process we want to do is we want to divide all terms by the highest degree in the denominator. So look at the denominator, what's the highest degree? I see x squared. So what I'm going to do here is I'm going to take a limit as x approaches infinity, same thing, but I'm going to take 3x and divide it by x squared. I'm going to take the x to the third divided by the x squared. Remember, the highest degree in the denominator. I'm going to take the 2 divided by x squared and the x squared and divide by x squared. And what happens here is you now have the limit as x approaches infinity. When you reduce this, you get 3 over x minus this one, you'll get simply x. When you simplify that, when you simplify this, you have 2 over x squared. When you simplify this one, you get 1. Alrighty, so what does all that mean? Well, now plug in infinity. Alright, when you plug in infinity, you get 3 over infinity, which might seem like nothing in particular, but really think about it. If I have a number 3, and I divide by an infinitely large number, what that ends up being is 0. So this one actually ends up being 0. This one ends up being infinity. When you plug in infinity, you get infinity. Alright, this one becomes 2 over infinity squared. Well, 2 over a really, really big number squared, even bigger. Okay, so isn't that just going to be a 0 again? Because any constant divided by an infinitely large number is basically going to end up being 0. Alright, and then this one, this negative 1 down here. Alright, so what does all this become? Well, what is negative infinity divided by negative 1? The answer is infinity. So what this graph of this function is doing as you go to infinity is going to positive infinity. It's basically going up. As you go this way, the graph's going up forever. That's what that's saying. Alright, so let's do another one. The limit as x approaches negative infinity. Be careful, there's a little negative there, might be hard to see. So when we plug in infinity, you get indeterminate, you get infinity over infinity. So we're going to divide top and bottom by the highest degree in the denominator. So in the denominator, highest degree is x to the third. So we're going to take the limit as x approaches negative infinity of 3 over x to the third minus 4x over x to the third over 2 x to the third divided by x to the third minus 1 over x to the third. So what did we do? Took the highest degree in the denominator, divided each piece by it. So when we do that, we get the limit as x approaches negative infinity That one simply is still 3 over x cubed minus, that becomes 4 over x squared. This one becomes, what, 2? And this one still is 1 over x to the third. And when you plug in infinity, negative infinity in, sorry, when you plug in negative infinity, you have 3 over negative infinity to the third power. Just that's 3 over infinity, which is 0. So we get 0 minus, well, another 4 over infinity, or negative, actually, negative infinity squared would be positive infinity, and it doesn't really matter. 4 over infinity is still going to be infinity. 0. 4 over infinity is 0. So that's 0. Okay, that's a 2. And this becomes, what does this become? 1 over infinity again, so, well, that would become 0. Minus 0. Alright. So what does that become? Well, 2 minus 0 minus 0 is 0 over negative 2 over 2. So that's a negative. It looks like a negative, doesn't it? It doesn't really matter, because what's 0 divided by 2? Or 0 divided by negative 2 doesn't really matter. The answer is 0. So what does that mean? What that means is I have a horizontal asymptote at 0. Okay? So you could write this as I have a horizontal. I actually do have a, doesn't ask for this, but a horizontal asymptote at y equals 0. There's actually a horizontal asymptote at y equals 0. That could be useful. And some questions you'll run into where they ask for, what's your horizontal asymptote? The limits to infinity give you horizontal asymptotes. So as you go to negative infinity, you get a horizontal asymptote of 0. The graph will go towards 0 as you go like this way forever. Alright, this last one here, same process. So it kind of gets redundant. Sorry about that. The limit as x approaches infinity. The highest degree here is x to the third, so negative 2x cubed over x to the third plus x over x to the third over 5x to the third divided by x to the third minus x squared over x to the third. Alright, hope you're getting the hang of it here. So what does this happen? What do we get here? We now have the limit as x approaches infinity. And this one becomes negative 2. This one becomes 1 over x squared. This one becomes 5. And this one becomes 1 over x. So what does all that mean? Well, let's think about it. Put in infinity in, that's 0. Put infinity in, that's 0. So hopefully you realize we have negative 2 plus nothing over 5 minus nothing. So what does that equal? Negative 2/5. That is the limit as x approaches infinity, which also means is that's the horizontal asymptote at y equals negative 2/5. Alright, so that right there is 3 different problems finding the limit as you approach infinity, which talks about asymptotes, horizontal asymptotes, or it talks about the end results. Remember this one kept going as you go to infinity, kept going up forever. This one has a horizontal asymptote in the negative direction of 0. It'll probably have for the positive, because if you plug in positive infinity into this, you would get 0 as well. So both are going to be 0. But in this situation, it was asking for a negative. And in this one, when you do this, you get negative 2/5 of a horizontal asymptote, or the answer is negative 2/5. Now there is a shortcut when you do this enough. Hopefully you're kind of seeing it. You just look at the denominator, and in your mind you can actually look and do all this division in your head. Alright, and you just kind of look, okay, x to the third, and you could just kind of cancel these out, and you can do little shortcuts. When you get used to it, you could just right off look at it, negative 2/5. You could look at this real quick and see 0. You could look at this and say infinity. There are ways to catch on to that. Hopefully you'll see those little shortcuts as you do these problems. Look for them again, because when you divide here, like whenever the power is higher than on the degree is higher on top than on bottom, it's going to be infinity or negative infinity, depending on what you're plugging in, depending on how things work out. Yeah, hopefully this helps. Limits to infinity, that's what we're talking about.